Professor. I'm going to start out by showing you the targets and associated movements using the UR3 robot. Afterwards, I will discuss some of the problems that I ran into that forced me to use the joint motion. And hopefully by the time we have our next RoboDK assignment, I can figure those out. So we start out at the home position where the robot is oriented as shown. Next, we move to the ready position, which, if we zoom in, we see is here above the bearing. After moving to the ready position, we have a joint motion to the align to engage. From this point, we engage the bearing, lift it clear, and move perpendicular to the first slot. Next, we align the bearing so that it can travel along the slot. We have a linear motion up to the start of the arc, and the arc is defined by 3 points, which are added as the last two are mid-arc and end-arc. We can see it travel, and by the way, throughout this whole slot, positioning in the middle of the two faces. We then have a linear motion to the end of the slot and lift away for clearance. We then have a linear motion to the start of the ramp, a linear motion up the ramp, and we begin to get ready to disengage the bearing from the tool. So first we move above this disengage area. Had to force a joint motion here to get the right orientation due to joint limits. We then lower and move away to disengage. At this point, hopefully the bearing comes off, and finish by clearing away from the ramps. We then return to the home position. So if we wanted to see this all play out, we could run the program and display the path. So as you can see, these large loops, where often the robot is intersecting itself, are the joint motions, and they are workarounds that allow me to run the rest of the program, and hopefully I will learn how to properly define my targets to avoid this in the future. So running the program, go to ready, engage, go along the slot, including the circular arc, lift away from the slot, engage the ramp, move up the ramp, and it's time to get that bearing off, so we lift ourselves away from it. If we wanted to play it in a loop, you can do so by selecting loop and running. Here I had it slowed down because I was really trying to change the the configuration of the robot to different angles, but even when I forced it and tried to define the targets by joint angles, as seen by the green targets on the tree on the left, they were not sticking. So here we're getting to disengage, and it starts to loop again. But I'll go ahead and stop it. Now, here the issue is that when the program is running the home position, it's in this orientation. This is different than the home orientation that I defined, and I'm not exactly sure why it's doing that. Because if we had started from that home position, maybe this ready position might have had a more promising condition. As you can see here, these joints are almost aligned, which could be part of the reason that we couldn't do a linear motion to get ready to engage the bearing. We might be approaching a singularity here. I tried manipulating the joint angles myself, And if instead of having this upward facing angle, we had a downward facing angle of those two links, then it would have been more possible to smoothly move into the engage position. Again, I tried to force those joint angles on the configuration of the ready, but my selections don't stick, and I'm not sure why. So as you see here, aligning to engage, we had to do a joint angle to that, even though I tried defining the angles. And after that, these targets are just coordinate based rather than joint angle based. So this is my submission, complete with an explanation of the errors, and that completes my presentation. Thank you, and have a good weekend.